On this video, we're going to be talking about finding the limit of the sequence. For these two particular problems, we're going to be applying one of the properties of limits of sequences, which is simply taking the limit as n goes to infinity. One of the quickest ways to get to the answer is by interpreting your equation and finding, in this case, the horizontal asymptotes. If you recall back, one of the ways to find the horizontal asymptote, there's really three rules. I'm just going to explain the rule that applies on this situation. One of the rules is if the highest degree on your numerator and denominator match, like in this case, they do, second and second. Therefore, we can take their leading coefficients and then create a fraction. So therefore, our answer is 5/1, and our solution will be 5. Okay, that's one of the quickest way of doing it. Again, that's one of the rules for asymptotes, in particular horizontal asymptotes. Okay, another way we can do it is by taking the limit. Okay, so on this example, we're going to take the limit as n goes to infinity of our sequence. Okay, our sequence in this situation, let's take the limit as n goes to infinity. Our sequence is 5n squared over n squared plus 2. Now, because we're taking the limit again, we assume that we're going to divide by the highest power. That's one of the techniques that we can apply on this problem. So the limit as n goes to infinity, and then the highest power in this situation is n squared. So 5n squared, that's originally, and then divide that by n squared over, we have an n squared, and now we're dividing it by n squared plus 2 divided by n squared. So on this problem here, we can see that our n squared will cross out, and we're left up with the 5 in our numerator. Now in our denominator, this simply becomes a 1. And then here we end up with 2 over n squared. And now 2 over n squared, as we take the limit as n goes to infinity, so this becomes a super large number. And then when we have a relatively small number divided by a large number, we can assume that's 0. Therefore, this goes away, and our answer is 5/1, or we can simply say the answer is 5. On this other example, we're going to apply the same technique, just taking the limit as n goes to infinity. So we're applying the limit as n goes to infinity of a sub n, and this is equal to simply the limit as n goes to infinity of 2n over the square root of n squared plus 1. So now let's try to identify the highest degree. So we can clearly see that our highest degree will be n to the first. Why is it n to the first and not n squared? Well, if you look at it, n squared is within the square root. So therefore, if you were to simply think of n squared, not the plus 1, when you take the square root of it, it will simply be n to the first. Therefore, n to the first will be our highest degree in this problem. So we're going to expand our view on this one. So we're following the same procedure, dividing by the highest term. So the limit as n goes to infinity of 2n, and then divide by n over the square root of n squared. Now, because we have chosen n squared to be our n to the first to be our highest degree, when we bring it inside the root, we have to call it n squared. So we have an n squared plus 1 over n squared. And I can make a side note on this particular problem. So we know that our highest degree is n. So if we want to simply put that number, or rather that variable, inside the root, so that will simply be n squared. So that's why in here, inside the root, we call it n squared and not n. So we can cross out the n's and we end up with 2 over. Down here we have the square root, and then n squared over n squared becomes 1 plus 1 over n squared. And like the previous example, we see that when we plug in the infinity for our n, this terms cancels out. And then we're left off with 2 over the square root of 1, which simply simplifies as 2. That will be our limit. Alright, so here we have 2 more examples. We're going to be applying the same property, the limit as n goes to infinity. So let's go over that. So the limit as n goes to infinity of a sub n, our sequence, and that will be the limit as n goes to infinity, 6 plus 2 over n squared. And in this particular example, you can see that we don't have to manipulate anything really, because this is just a simple plug-in. So we plug in our infinity here, and you can see that I'm just gonna emphasize that we have 6 plus 2 over infinity squared, and this is equal to. So again, in infinity, or rather any number divided, not really any number, but a relatively small number divided by a super large number such as infinity will always be 0, or rather approximating 0. Therefore this will go away and our answer will be 6. Now going over the example of cosine 2n. So in this situation, let's do the same process. Limit as n goes to infinity of a sub n. I'm just trying to be technical here. So again, the limit as n goes to infinity of cos 2n. And again, this is a simple plug-in. So the limit as n goes to infinity of cos, and here's where we plug in 2 over infinity. And then we know that 2 over infinity, of course, is 0. So we have the limit as n goes to infinity of cosine 0. And cosine 0 will be equal to 1.